Hi everyone and welcome back. In this video, we are going to see how we can containerize ELK stack, Elasticsearch, Logstash, Kibana, and how we can really integrate that with the Nestjs service or Nestjs APIs, which is producing logs, and how we can push that logs to Elasticsearch through Logstash to Elasticsearch or through maybe a file beat to Logstash to Elasticsearch and then visualize it through Kibana. So this is our simple setup, and what we are doing in this setup is try to achieve this kind of a structure. I mean, Beat is also actually a part of the ELK stack because Beat can extract the logs coming from either a heartbeat, from file beat, audit beat, metrics beat, or if you don't want to use Beat, then just use Logstash. Your Node.js can be pushed to logs to the Logstash, or this file beat, which is actually a part of a beat platform, can read the logs from a particular file. So if you see that you are pushing the logs to a particular dedicated file or directory, then file beat can read it from there, push the logs to the Logstash, and then Logstash will parse, transform it, and push that to the Elasticsearch. Or let's say you are using Node.js or Nestjs, you can push the logs directly to the Elasticsearch also, that can be visualized through Kibana. So that we are going to play all these things in this particular video. So let's set up a Docker Compose file. These are the fixed set of containers, Elasticsearch container. And then we have, I think, Logstash. You don't need to struggle much on setting up the these containers. You can just copy and paste this Docker Compose file. It has all the configurations, all the required port which you need to expose. Docker Compose is actually really helpful that you get all the containers pre-configured. You don't need to worry about the configurations which you are putting inside a Logstash, Kibana, ELK. Obviously you need to understand, okay, what is the volume mapping, port mapping, what is the network, and how these containers are going to spin up, what port they are exposing, under which network they are, and any specific environment variable which you are specifying, right? For the Elasticsearch, I'm going to bootstrap it from the image which I'm going to pull from the Docker Hub. This is the container name. And then we have Logstash image volume mapping, because for Logstash I'm going to provide a Logstash configuration file, logstash.yml, that is going to be get mounted with the container. Logstash configuration will decide, okay, what will be the input, what transformation I want to do, and what will be the output. Logstash, serves a very specific purpose. So whatever the data, the logs you are getting, you can actually apply the transformations and filtering on top of that. Kibana is for visualization, so nothing much here. And a file beat. File beat is actually looking for a particular directory like microservice logs. Inside this directory, if you put the files, then this file beat will read those files from that directory. Okay, now let's spin up these containers. So here we can create first these files like file beat folder, Logstash folder. Inside Logstash, we need to create a logstash.yml also. So this is the Logstash configuration. Configuration, if you see, the Logstash contains three things: input, output, and a filter. I'm not doing much on the filter part, just not a lot of transformation. Input is actually can be a TCP or can be coming from the beats. So the input source in the Logstash can be a file beat, heartbeat, or whatever the beats platform we are using. So beats will push the message to the 501, and any particular logs, let's say I'm using Node.js, Nestjs, so I will push the logs to the 5000 port. Then it will just transform it, doing nothing on the filter part, and output will be the Elasticsearch. The Logstash playing very critical or very important part in deciding the index. So here the index of the Elasticsearch will be app. You see the Elasticsearch configuration here. Inside Elasticsearch, we are, on the output of the Logstash, Elasticsearch is running on 9200 index, because Elasticsearch is a NoSQL. So to push something and store something, it actually creates the index. Like if you aware about MongoDB, which contains the database as a collections, database tables are collections, and you create different databases. So here that is called indexes. Inside indexes, you have columns and all these things. So index is app and the date stamp. All those configurations inside a Logstash config and Logstash YML. And you can also have a, so this is the file bit. File bit is file bit configuration. It is saying, okay, what is the stream of the file? From where are we going to read the input? The file bit is also going to read the data from the input. It is going to be reading from this particular directory, and file bit actually will process, it actually sends the output to the input of the Logstash. So there is a file bit here, then it will post the message to the Logstash, and then Logstash will push to the Elasticsearch. This is how it works. Okay, then we have Kibana, which is running on 5601. Output of the Logstash, output is going to the Logstash, which is running on 501. So we have Kibana, 5601, Logstash. All these are the containers, file bit containers, and we can just set up them using Docker Compose up. I wrote a blog also if you want to have a basic understanding about all these components, what all these components are. Elasticsearch, a highly scalable distributed search engine. It's not like, okay, Elasticsearch is being used for logging. You might be mistaken, right? I have used Elasticsearch for providing a full text based search with the Nestjs or Node.js. It is using that index, and same index we can use like, okay, I want to store the inventory of the food cart application, or like Mintra, where you want to search for the clothing items, or Uber Eats, where you want to search for a food item. Those kind of extensive token based, text based, full text based search, you can use Elasticsearch. It also used for analytics indexing. So for the logging, we'll create a log index and we'll push that data to the NoSQL. And here now next is Logstash, is a central component of ELK. It is actually three components: data ingestion, data processing, and data enrichment, right? Input, processing, and output. So Logstash has a flexibility to integrate it with. Kibana is a powerful visualization tool, is a part of ELK stack. It is actually super friendly interface. It reads the data from the Elasticsearch index. So all these things, FileBit is a lightweight agent that is part of the ELK stack, is primarily responsible for shipping logs to the various source, to the Logstash for centralizing processing. So FileBit is putting the logs to the Logstash, right? FileBit read the logs from the file and push it to the Logstash. So now do just Docker Compose up, and we can see everything is getting spin up. So that's advantage of having Docker Compose up file. That all are spinning up, and we can just check. How you will check the Elasticsearch? You can just do localhost 9200, and it will give you this single node cluster has been created for the Elasticsearch, and you will see the same output. That means the Elasticsearch is up and running. Same way you can also check for other port like 5601 where the Kibana is running. 5601, this is Kibana add integrations. So here this is Kibana is actually providing you the observability, analytics, and security. We are just going to use the how I can grab the logs which are stored inside Elasticsearch index. Okay, so we are just going to use the dev tool of the Elasticsearch. So here we open the dev tool, get/search dev tool. You can get it from here, and you can hit it here, and you can see that you are connected. So by default it is already connected to the Elasticsearch. When you spin up 5601 and inside a /search index, it is trying to search but there is no index available in the Elasticsearch. It's totally empty. So it took 0 seconds and returned you empty result set. Now what we will do is, so this is the setup which we are going to produce. So this is the Nestjs app, and we have three different things. WINSTON, which is going to use Elasticsearch transport, put the logs to the Elasticsearch directly. Or you can just use a Logstash transport in the WINSTON library and put the log to the Logstash. Logstash will push it to the Elasticsearch and visualized by Kibana. Or you can use the FileBits platform, which will push the logs to the Logstash, Logstash to the Elasticsearch, and Kibana will visualize that. Okay, so let's try to have the same kind of setup in our code also. So let's start our application here. What we'll do is we can just create a simple new application, ELK Nestjs demo. So when I push it, you can also take a look onto the same setup. I'm using Nest CLI to spin up just a simple hello demo application. This is there, and then I will just install the required modules. Like I need to have a WINSTON module added. So I will just do npm install minus minus save WINSTON, and then I will configure the same service like, okay, logger service, logger module, logger config with all the different transport modes and WINSTON daily rotate file. Okay, and I will do npm install. All the modules are ready, and inside this I can just create a same logger module. So this logger module I have created in the previous video, which contains all the different logger transports. It is giving me the logger object, and this is logger module. Now I will be just what I will be doing. So this is the logger module. Just import this because we have custom logger created with the Nestjs, and here you can inject the logger module, logger service, app logger service, and then just do a simple logging. So whenever the API gets hit, we should be able to generate the logs, write it to the log file, put it to the console, and then visualize the same thing on the Elasticsearch. But how it will visualize on the Elasticsearch? We need to somehow write the transport, Elasticsearch transport in our logger. So we are just setting up the simple setup, and then we will write the logs. So now I start the application. I can see these logs on the console and also on the file, because we are using both the type of transport, console and file based transport, and these logs are getting popped up. And this is the file based logging, because we are using both the transport. One is console based, one is a file based with the daily rotate file. Now interesting thing, we need to add another transport, WINSTON Elasticsearch. So WINSTON module which we are using should be able to push the logs to the Elasticsearch directly. So there is no role of Logstash in this particular setup. We are trying to hit directly to the Elasticsearch. So Elasticsearch and WINSTON module, just get them added, and then we can just create the Elasticsearch instance. We need to install all these modules, Elasticsearch transport, Elasticsearch client, and create the client object using Elasticsearch instance. So here const Elasticsearch, Elasticsearch options we can provide. So if you see the ES transport mode options, yeah, first of all, this is the URL, like, okay, what is the Elasticsearch endpoint, which we can configure in the env, or this is localhost 9200, and the options level info client. What is the client object which we are using? So here, if you see the client equal to new client, we are passing Elasticsearch URL, because client is nothing but the instance of Elasticsearch, and then format, transformer, how we are going to transform the data, and then Elasticsearch transport we are getting from the transport, and just add this another transport inside an array, and that's it. This is the minimal setup we are doing. Readable stream is not defined. I think I need to switch to the latest node version. I mean, if I use NVM 20, then it really works. So you can stick to the node NVM 20, node version 20.x. And I will be just hitting this URL so that I can generate some logs, which is nothing but hitting the health check endpoint, localhost 3000, and just printing hello world, because there I'm putting these logs. And here, important part, just go to the same dev tool and hit search, and you should be able to see that total 14 occurrences are there, and you can see these logs are being written. Index, what is the index? Index is actually database name, you can see. A unique ID, score, and the source. Source, actually, this is the data which we have pushed inside of the logs. And how this is being pushed, we can also check our Docker Compose logs, what is happening over there. Okay, but these are the records which has been pushed automatically, and this is my Kibana logs. So I can go to the dashboard, create visualization. I already have this particular index, and here you can see the whole logs being popped up in the Elasticsearch. How that is happening? Because we are using ES transport and putting the logs through the Nestjs to the Elasticsearch, and I can see all those things here. So what is the overall advantage? Let's say we are writing a microservices, and maybe they are distributed, but we wanted to centralize the logs. So you can set the context equal to application microservice name, and you can push those logs real time to the this Elasticsearch platform. Here you can have an ELK cluster, and push all the logs here, and then you can visualize it through the Kibana. And there are different ways of visualizing it. Like here currently we have just a few fields: context, level, message, timestamp. You can also have a status code, API name, API URL, API path. All those arguments can be used to trace the static metrics. Lots of things can be analyzed using that. Currently it's just like, okay, this index is database where you are actually putting the lots of data inside it. So now I'm trying to put these logs on different modes, like, okay, this logger.log, one error, 3 different log level I'm using. And then this is the logs it is generating, and you can see these are the 3 different log levels I'm using: info, one, error. So similarly, the same statics is getting exposed here. Okay, these many are the verbose, these many are the info logs, warn logs, and error logs. All these are being popped up exactly the same way, which I have pushed from the Nestjs logger service. And here this is simply, so what we have done is, from Nestjs app, I used WINSTON Elasticsearch transport, and I'm putting the logs directly to the Elasticsearch. Let's change this behavior. I can just use ES transport mode also. We can use the Logstash, WINSTON Logstash. Logstash will push to the Elasticsearch. And how Logstash is doing that transformation, that we will see in the Docker Compose. So here I will be just using another transport strategy, WINSTON Logstash. Then I will add another transport. Maybe comment this Elasticsearch transport, so we can have a room for adding another transport and see that logs here. So I will just create an instance of it, Logstash transport equal to new Logstash transport. So here we are passing the host, localhost, and port is 5000. Okay, this is because Logstash is exposed here. Logstash is listening for all the logs coming to the localhost 5000, which we have seen in the Logstash configuration. And here add another transport, Logstash transport, and maybe comment the Elasticsearch one. We will play with one at a time. And now start doing the same thing. Put more logs after starting the application. Hello world, and here let's see what is happening. So here in our logs, Docker Compose logs, you can see these are the logs which is being coming, because Logstash is taking that as an ingestion, data ingestion, transforming it, and then pushing it to the Elasticsearch. And same I can see in the Docker Compose logs. Okay, level, message, version, trace, timestamp, and the event. All these are actually pushed through the Logstash. Logstash is putting that to the Elasticsearch. And you can see all the same set of messages are being pushed. So here I just want to change the message name, debugging the log trace from the ELK, just to see, okay, things has been changed when you start putting the logs to the Logstash. I just changed the message syntax, and this is the Logstash configuration, which is saying input can come on the TCP port 5000 or 5001 beats port. I will filter it and I will push this to the Elasticsearch as an output. So this is the input, filter, and output. And here I have created a different index name. Now the index name is demo datestamp. Let's see this, how we can visualize this in the Kibana. I do Docker Compose up again. So it should start writing the logs to the new index, which I just have changed to the Logstash YML file. I will just hit some hello world endpoint, and then we'll go to the Kibana. These logs are popped up for the Logstash. And here I can see my index is changed here in the search, demo 2024, and the message name is also changed, debugging the logs trace from the ELK. This is the index, this is the message is coming. Now we can just create a dashboard. So here the path name, index pattern. Index is actually the index which you have created in the ELK, Elasticsearch. So it is prefixed with the demo. So you can just hit demo / dash, and I can see that there is one index already there, and the dashboard name, create visualization for it, create dashboard, create visualization, and you can see all these things are being popped up. And here these are the messages which will start popping up. I need to fix, I think, the date range. so that I should be able to see the data coming up. Yes, now the data is coming after fixing the date range in the top bar, and proper log messages are coming. Here you won't be able to see lots of things happening because I'm just putting one simple console log and trying to see how this is working on the Kibana side. But when you have an intense logging, different log messages, then you should see an intense graph being popped up. I mean, it's not like, okay, you can just set only 5 6 arguments. You can put n number of arguments through the WINSTON. Okay, your API version, context, API path, API URL, whatever the context or meta argument you wanted to set, that can help you for the logging. All those things can be configured, and then same things we can use here, like in the Prometheus Grafana is actually for visualization. Similarly, based on those data attributes, we can design the access coordinates and can see the visualization here in the Kibana. So that's all, guys. This is how the whole ELK stack work. We can also have a about simple demo about beats. Beats is actually reading that from the file. So your microservice is generating a logs to a particular directory. From there, we can read, and that file beats actually pushed to Logstash through Elasticsearch and then Kibana. It's the same path. Either you directly push, or push it through the Logstash, or push it through beats, file beats. That's all, guys. So this is kind of done. Now we are going to cover more interesting topics in the coming videos.